Hey guys, Mr. B here, and this video is for the Conservation of Momentum Lab. So what we have set up here is a long piece of foam that is attached to the wall, and we have some books here set up to help us give an arc, and then we have a meter stick set up so you can see how high up the wall that we have our foam insulation. And right now we have our insulation set to about, I don't know, maybe about 56 centimeters, which is maybe a little bit too high, but we want to make sure that it's at least 30 centimeters up the wall. And so what we're going to do is we are going to put some markings on this foam insulation, and that then is going to give us different heights that we're going to drop our marbles at as it rolls down this foam, and we have some collisions happening down at the bottom. So we're going to mark this up, and I'll show you where we want to put our tape marks. Here we go. Alright, so the first thing here is we're going to take our meter stick, we're going to set it up next to our foam straight from the ground, and at 5 centimeters up we are going to put a piece of tape, and this piece of tape is going to mark where our first marbles are going to be dropped from. Okay, so this is at 5 centimeters, and we'll do another one at 10 and 15 centimeters. Alright, so the next one is going to be at 10 centimeters, so we can see again 10 centimeters up from the ground, and we're going to put our piece of tape on our foam insulation so that we can make a mark, and then we know we're going to drop our marbles from this height. Alright, then our last one here is going to be at 15 centimeters, again straight up from the ground. We're going to put a piece of tape to mark where our marbles are going to drop from. So we have 3 pieces of tape now. We have 10, 15, and 5 centimeters. And yeah, now we're going to go into the lab part. Alright, so now we're going to take 6 marbles, and starting at 15 centimeters from about where the bend in the pipe is, we're going to put our marbles touching each other. So we'll just line them up. And again, we're going to have 6 total. And just make sure that they're touching. So push them all together, and then they're good to go. Alright, so we're going to take our first marble, and we're going to set it at 5 centimeters. And we're going to let it collide with the ones at the 6. So in 3, 2, 1, go. Okay, so we're going to write down how many marbles got knocked out in that one trial. Alright, trial number 2 now, we're going to drop 1 marble from 10 centimeters. And we're going to make note again of what happens. Here we go. Okay, so write down how many marbles got knocked out in that trial. Alright, here's our now 1 marble from 15 centimeters in 3, 2, 1, go. Alright, so again, record on your sheet how many marbles got knocked out. Alright, so now we're going to take 2 marbles from 5 centimeters and drop them down. So let's put them in. And 3, 2, 1, go. Okay, so on your sheet, put down how many got knocked out. Alright, so we're going to take 2 marbles now from 10 centimeters, and in 3, 2, 1, go. Alright, so on your sheet again, write down how many got knocked out. Alright, now 2 marbles from 15 centimeters, in 3, 2, 1, go. Alright, so again on your sheet, write down how many marbles you see got knocked out. Alright, so now we're going to take 3 marbles from 5 centimeters. Ready, in 3, 2, 1, go. Okay, so make note of how many marbles got knocked out for that trial. Alright, now trial number 2 with 3 marbles from 10 centimeters. In 3, 2, 1, go. Alright, so write down on your data table how many marbles got knocked out. Alright, last trial, 3 marbles from 15 centimeters. In 3, 2, 1, go. Alright, so write down on your data table how many got knocked out. Alright, so now we have 4 marbles starting from 5 centimeters. In 3, 2, 1, go. Alright, so write down on your sheet how many marbles got knocked out for that trial. All right, so now we have 4 marbles at 10 centimeters in 3, 2, 1, go. All right, make note on your data table how many marbles got knocked out. All right, 4 marbles from 15 centimeters in 3, 2, 1, go. All right, so make note on your data table how many marbles got knocked out. All right, so now for the second part of the slab, we're going to be having to add one more tape mark to our foam. So at about 20 centimeters, we're going to add one more piece of tape and then go from there. All right, so for the second part of the lab now, we're going to take one marble, we're going to put it at 5 centimeters, and we're going to observe the speed of the marble as it comes in and the speed of the marble that leaves. And we want to see, is the speed of the marble that's coming in faster, slower, or the same speed as the marble that leaves? So in 3, 2, 1, go. All right, so did that marble that came out look like it was traveling faster or slower, or the same speed as the marble that came in? All right, so now same thing, but now we're going to drop the one marble from 10 centimeters. Again, is the speed of the marble the same, slower than, faster than, or equal to the speed of the marble that leaves? So in 3, 2, 1. All right, so put down what you think you saw. All right, so now one marble at 15 centimeters. Here we go. In 3, 2, 1. All right, so again, put down on your data table. Do you think it was the same speed, faster than, slower than, or equal to? All right, one marble at 20 centimeters. In 3, 2, 1. All right, so I'm going to take 2 marbles at 5 centimeters, and again, we're going to make note of the speed of the marbles coming in and the speed of the marbles leaving. So, in 3, 2, 1. All right, so was that faster, slower than, or the same speed? All right, 2 marbles at 10 centimeters. In 3, 2, 1. All right, write down on your data table what you think you saw. All right, 2 marbles at 15 centimeters in 3, 2, 1. All right, put down on your data table what you saw. All right, 2 marbles at 20 centimeters in 3, 2, 1. All right, put down on your data table what you think you saw. All right, so now we have 3 marbles at 5 centimeters. Again, I want you to make note of the velocity of the marbles coming in versus the velocity of the marbles leaving, and see if they are coming out faster, slower, or the same speed as the ones that are coming in. So in 3, 2, 1. All right, so put down what you think you saw. All right, 3 marbles at 10 centimeters in 3, 2, 1, go. All right, put down your observations. All right, 3 marbles at 15 centimeters in 3, 2, 1, go. Oh, we lost a marble, but I think you can still make some observations for that one, so write down what you saw. All right, last one, 3 marbles at 20 centimeters in 3, 2, 1. All right, so write down what observations you saw. Hey guys, Mr. B here. So this now is the post-lab questions. We are done with the lab and we are done with dropping some marbles. So let's answer some questions. So first one in the analysis part, it says number 1, describe your results from data table number 1. So in the first data table, we had marbles that were being dropped from 5, 10, and 15 centimeters, and we were making note of how many marbles were getting knocked out from the row. So just put down, some of the observations that you made from that part of the lab and just whatever you have in your data table. Doesn't need to be a super complicated answer. All right, let's take a look at number 2. It says, describe your results from data table number 2. So in the second data table, we had information about marbles and their speeds. So we were dropping marbles and we were trying to make note how fast were the marbles when they were coming in versus how fast were the marbles when they were leaving. So again, just describe what you have in your data table and what observations you made. It doesn't have to be anything super complex. All right, so number 3, reviewing data table number 1, how does the number of marbles and their release height affect the marble's momentum? So I'd like you to pause the video and try answering this question, and then we'll go over it together. Okay, so here's how I interpret it. The number of marbles and their release height affected the momentum by increasing it. So the number of marbles that we add, the more marbles we have, the more mass we have. Momentum, remember, comes from two things, mass and velocity. So the more marbles we have, the more mass we have, which increases momentum. And also, the higher up we drop the marbles from, the faster they're going to be traveling, and therefore they have a larger velocity, which then also increases their momentum. So both the number of marbles and the height at which they are dropped both will increase or decrease the momentum of the marbles based on if we have more or less marbles and at a higher height or a lower height. All right, number 4, what conclusions can you make from data table number 1 regarding the total momentum of the released marble and the total momentum of the marble knocked away from the row? So I would say that the total momentum of the marble that was released and the momentum of the marble that got knocked away would be the same. Now remember, this lab was on the conservation of momentum, which basically means that before a collision happens and after a collision happens, the total amount of momentum before and after is always going to be conserved. So all the momentum that the first marble had got transferred through all those marbles in the middle, and then it was in the marble that left. So the momentum beforehand and the momentum of the marble that got kicked out should have been the same. All right, number 5, what conclusions can you make from data table number 2 regarding the total momentum of the released marble and the total momentum of the marble knocked away from the row? So this one, we are trying to look at the speed of the marbles that were coming in and the speed of the marbles that were leaving. And I would say that the speed of the marble coming in and the speed of the marble that was leaving was the same. So if it was the same, that means that the momentum would have been the same as well, because our mass was the same. We had one marble come in, one marble come out, or two marbles come in and two marbles come out. So the mass didn't change. And I think the speed of the marble coming in and the speed of the marble leaving was also the same, which means their velocity was the same, which then ultimately means their momentum was the same. So I think the momentum of the marbles coming in and the momentum of the marbles leaving was the same for our second part of the lab, just by making those observations and seeing the speeds of the marbles coming in and going out. All right, last question here. We have crash questions. Number 1, describe the collision picture below in terms of momentum if the truck has 4 times the momentum of the car before the collision. All right, so pause the video and try answering this question, and then I will help explain it to you after. All right, so describing the collision in terms of momentum. If the truck has 4 times the momentum of the car before the collision, that means that after the collision, the car is going to have 4 times more momentum than the truck. And this is because when the truck collides with the car, all of its momentum will get transferred to the car, and all the car's momentum will get transferred to the truck, in which case, because the truck had more momentum than the car, after the collision, the car will have 4 times more momentum than the truck because it gets transferred across. Okay? So that's how I would answer that question. Hopefully you answered something similar to that. But anyway, that is it for this lab, guys. That was the last question. So thanks for sticking with me. Hopefully you learned a little bit about momentum, and this lab wasn't too bad to watch and go through. But regardless, thank you again for watching. And if you have any questions, as always, feel free to email me, chat with me in class. You can do a Google Meet, and just make sure that you get your questions answered. All right, guys, I'm Mr. B. Thanks for watching. See you in the next one.